Alright, in today's lesson we're going to be finding the exact value of trigonometric expressions. All these trig expressions will come right from our unit circle. So let's take a look at the first example. So the first example here, we want to find the tan of pi over 4 minus the sine of pi over 6. So again, answering these questions here, the first step is to take a look at unit circle and see where these values are located on our unit circle. Alright, so taking a look at our unit circle here, I have pi over 4. The measure of pi over 4 here, you can see that point there is going to be root 2 over 2, root 2 over 2. For that value, obviously, root 2 over 2 divided by root 2 over 2 is 1. And then for pi over 6 here, we're taking the sine of pi over 6. That's going to be your y-coordinate, and that's going to be 1/2. So obviously 1 minus 1/2 is 1/2. All right, let's take a look at the next example here. Here they want 4 cos 60 degrees plus 3 tan of pi over 3. So again, these are two different. One is in degrees, one is radians, but it doesn't matter here. All right, going ahead and evaluating the second one here, you'll notice that at pi over 3, the point in the unit circle corresponds to 1/2 and root 3 over 2. So if I'm looking for the tan of pi over 3, that's going to be sine over cos. So in this case here, if you want to find what the tan of pi over 3 is, we will be taking our root 3 over 2 and dividing that by 1/2. That'll simplify to just becoming root 3. So the tan of pi over 3 is root 3, and it turns out that pi over 3 in radian measure is equal to 60 degrees. So therefore, when I'm looking for the cos of 60 degrees, that's just going to be 1/2. It's going to be my first coordinate here. So plugging everything in here, we get the following. So we end up getting 2 plus 3 root 3 for our simplified expression. Let's take a look at another example. Okay, for the next example here, I went ahead and drew our unit circle here. This time we're at 3 pi over 4 and negative pi over 3. At negative pi over 3, we're going to take a step going in the clockwise direction. You'll see that'll correspond to your pi over 3 point right here, if you recall, is 1/2 and root 3 over 2. So this one down here is going to be the exact same, except for your y-coordinate will be negative. So from here, we can quickly find our tan of negative pi over 3 is going to equal my sine value divided by my cosine value, and I'm going to get negative root 3 out of this one here. In the next one here, I want the cos of 3 pi over 4. We see that's the first coordinate. That's going to be negative root 2 over 2. So subbing everything in here, we get 6 times negative root 2 over 2 plus 2 times negative root 3, giving us negative 3 root 2 minus 2 root 3. All right, let's take a look at the next question here. So now our focus is at 2 pi over 3 and 5 pi over 2. 2 pi over 3 here, you see this is our first cut of pi over 3, and then this will be 2 pi over 3. So you see it's the same point, just reflected in the y-axis here, if you think of this as the y-axis. So we end up getting here, I'm looking for sine, so I'm getting the sine of 2 pi over 3 must equal root 3 over 2. And for the next one here, they wanted 5 pi over 2. This is every 90-degree slice, so we've got here, this first iteration is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and then back up top to here to 5 pi over 2. So it turns out that pi over 2, 5 pi over 2, 9 pi over 2, anytime you add 2 pi to this, again, that's the period of your cosine function, you're going to be back up top here. So 2 pi is equivalent to 360 degrees, so if I add it, I'm right back here at 5 pi. Do it again, I'm at 9 pi, etc., etc., etc. So with this one here, I'm looking for the cos, in which case that's going to be 0. So we get the following. We end up getting here 3 root 3 over 2. Let's take a look at some more examples. So in the next chunk of examples here, let's take a look here at this first one. They want us to evaluate all of this. First thing here is 40 degrees is not one of our special points on our unit circle. So we must have to do something else to simplify this. I'm going to first make the following observation. The cotangent of theta is equal to the cos theta over sine theta. Let's sub that into the following equation and simplify. And you'll see here I replace the cotangent of theta with cos theta over sine theta. And then I went ahead and sub that in, and you're divided by the fraction. So I multiply by the flip, I end up getting this here. This will simplify to become, you end up getting 1 minus sine squared of 40 degrees over cos squared of 40 degrees. But we know, using our trig identities, that this is equal to the cos squared of 40 degrees. And therefore, everything will cancel, and we end up getting 1. Let's take a look at simplifying the next expression. So for the next expression here, we have the sine of 50 times the cosecant of 410. First of all, the cosecant function, if you recall, is equal to, the cosecant of theta is equal to 1 over sine theta. So let's go ahead and simplify that. Now let's re-examine the sine of 410 degrees. Looking at your unit circle here, you see at 0 degrees, we start off on our positive x-axis on the terminal arm, a rotation of 360 degrees, and then what happens is that 410 degrees is actually going to be 50 degrees past where we were at here. This is going to represent 50 degrees, but it also represents 410 degrees. So therefore, in this situation here, the sine of 50 degrees is exactly the same as the sine of 410 degrees. So I can go ahead and sub in that 1 over sine 50, where I have the sine of 410, and you see these cancel off, and once again this reduces to become 1. Let's take a look at the next two examples. Alright, for our last chunk of examples here, we want to find the exact value of the other trigonometric relationships, given that we have the tan of theta equals negative 2/3, and we know theta is bounded between 90 and 180. So I drew a little diagram here. I know that my tan of theta is equal to negative 2/3. I know I'm in this quadrant here. So tan is going to be your opposite over your adjacent. So it's going to be 2/3. I can go ahead and find this length here. Calculating this length here, we can do Pythagorean theorem, in which case I get 2 squared plus 3 squared is the hypotenuse squared. Solving for h, we end up getting here root 13. So therefore, we can solve the rest of these trig ratios. I now know the sine of theta is going to be opposite over hypotenuse. So that's going to be 2 over the root of 13. And the cos of theta is going to be my adjacent over my hypotenuse. That's going to be 3 over the root of 13. And this 3 here is, as you can see, the cos is negative in this quadrant. So we're going to tack on a minus sign and we can solve. So in the next example here, we have the cosecant of theta is negative 4. This equates to becoming 1 over the sine of theta is negative 4, which means the sine of theta is negative 1/4. So I can go ahead and fill up my unit circle. Doing so here, we've got our right angle triangle in this quadrant. This time, again, they tell us that in the question, between pi and 3 pi over 2. And I know that your sine is going to be opposite over hypotenuse. And then again, I can solve for this here. Doing Pythagorean theorem, I end up getting the following. I end up getting x is the root of 15. And therefore, from here, I know the sine of theta is negative 1/4. I can go ahead and find the cos of theta, which is going to be my adjacent, which will be root of 15 over my hypotenuse, which is 4. And in this quadrant, cos is negative, so tack on that minus sign. And lastly, your tan of theta is going to be your opposite over your adjacent, which is 1 over the root of 15. And in this quadrant, your tan of theta is positive. So therefore, the exact values of our other trigonometric relationships here, sine, cos, and tan, are as follows. Okay, that concludes today's lesson on evaluating trigonometric expressions.
Yeah.